Hello, and welcome to Coffee with a Ranger. I'm Ranger Stephanie, and today we are going to cover the geologic story of Crater Lake. For thousands of years, nature's powerful forces have been at work shaping and filling Crater Lake's caldera. There are two main systems responsible for the formation of Crater Lake: the geologic and hydrologic cycles, also known as the rock and water cycles. Let us take a journey through time and discuss the interaction of these two systems and their work here at Crater Lake. If we travel back almost 500,000 years ago, do you think that there would have been a lake here? If you answered no, you are correct. At that stage in time, we would have been experiencing the birth of a composite volcano here at Crater Lake. Deep within the earth, convective heat results in the movement of the oceanic and continental plates. Due to tectonic movement inside the earth, there was magma pooling in chambers underground. As tectonic plates moved, they forced the magma above ground, resulting in lava flows and small volcanoes. Over the next hundreds of thousands of years, these lava flows and small volcanoes built upon one another, forming a massive composite volcano. Geologists refer to this volcano as Mount Mazama. Their research suggests that Mount Mazama would have stood over 12,000 feet in elevation and likely resembled one of its fellow composite volcanoes in the High Cascades mountain range. Have any of you ever seen Mount Rainier, Mount Hood, maybe Mount Shasta? If so, Mount Mazama would have had a similar appearance. It loomed tall, adorned in glittering glaciers. Many of these glaciers carved these steep basins in the sides of the mountain. Mount Mazama experienced times of peace and times of violent eruptions while it loomed tall. As we fast forward in time, we see a major change take place for Mount Mazama. Approximately 7,700 years ago, tectonic activity created movement within Mount Mazama's magma chamber, or the belly of the volcano. This movement resulted in an accumulation of immense pressure. This internal pressure caused expansion within the magma chamber. This expansion eventually led to a fracture in the side of the volcano. Ash shot 30 miles up into the atmosphere. Pumice spewed up and then down like rain. Molten material pushed outward, smothering anything in its path. Mount Mazama's summit developed a giant fracture around its entire circumference. The mountain lost its structural integrity and could no longer hold itself up. The summit fell into its magma chamber, forming a massive caldera. The term caldera is derived from the Spanish terminology cauldron and is defined as a large kettle or bowl-like structure. As the smoke settled, the scenery that was once picturesque now portrayed a devastated landscape. The volcano's belly was a gaping hole filled with melted rocks and gas hissing upward through fissures. As time progressed, the caldera transformed into what some geologists refer to as the gem of the Cascades. Heavy winter storms brought rain and snow. Any precipitation that fell on the rim or inner parts of the caldera filled the basin. Scientists speculate that it took approximately 700 years for the lake to fill from this precipitation. During that same time frame, Wizard Island erupted from the lake's depths and protruded the surface of the lake. Today we continue to receive enormous amounts of rain and snow, but the lake's level doesn't typically rise or drop by more than a couple of feet each year. Do you know what causes the lake to maintain its level? Some of the lake's water exits the caldera not only through evaporation, but also through seepage. Scientists think that there are porous layers of rock sandwiched in the caldera wall that essentially work as an overflow drain. When the lake reaches these layers, it exits the caldera and travels to an unknown destination. At 1,943 feet in depth, Crater Lake is the deepest lake in the United States and is attributed to having some of the cleanest water in the world. When we stand on the edge of the rim in the present and gaze out at the lake, we are looking at layers of time. Every volcanic layer embedded in the wall symbolizes the mechanics of Earth working under our feet. Every molecule of water journeyed here from some other location. These two systems are still working to shape and sculpt this ancient volcano into a gem protected for ours and future generations alike. Thank you for joining me and learning about your national park. If you have any questions, you can email us at this address below. Have a great day, and we'll see you next time. Cheers.